Great, welcome back. So in part one of this segment, we covered the actual functionality in terms of accessing streaming data via the Quotes API endpoint /quotes. And then we've left the visualization side to this video, as that entails a few things that should be discussed in isolation. And secondly, one of the main reasons for isolating this into one tutorial on its own is because future tutorials will build towards creating a live trading and backtesting terminal in either Plotly Dash or another equivalent framework that allows us to do that during these tutorials. All that code will be shared with you too. And obviously, all of that will entail a lot of visualization, treating time series, and the likes. Therefore, it makes sense to discuss practical considerations behind visualizing streaming data, as well as visualizing any time series data, really. And that serves well for our purposes here, as the quotes endpoint is constantly passing new data back to us, and we have to treat our time series in real time. For visualization, the process stream function that we talked about in the previous video, all of this code is available to you on GitHub after the publication of this video, uses Matplotlib. And in Matplotlib, what we go about doing is essentially creating a subplot with one row for this example, and a number of columns equivalent to the number of Darwins for which we've requested data for. Now, granted, this is an example, and this is not a very scalable way of doing this. But for example's sake, we've chosen 5 Darwins in this case to be plotted horizontally across one row of Matplotlib subplots. You can, of course, scale this to include as many Darwins as you like, and as many Darwins for which you are able to do so within API limits that I discussed in the previous tutorial. And optimize the way you chart these subplots, perhaps having some logic which calculates the number of rows and columns for you and then plots accordingly. But for this example, we'll be using a single row with as many Darwins as there are in the list of symbols we'd like real-time data for. We then go ahead and start constructing that object. Now, Matplotlib has animation that you can consider for real-time visualization of Darwin time series. But for this example, we're going to plot on the same figure that we create outside our loop, outside our data retrieval logic, and we pass the axes repeatedly to the plotting function so that only our axis data is updated and we see one figure on screen, as you can see over here. To give you an example. So here we have one figure that's been plotted at the very beginning, and we're repeatedly updating that figure's data by passing the axes to our graphics plotting function that we've written for you separately in DWX graphic helpers. Let's go over to that function and see what that entails. Since we're using Matplotlib, things are fairly simple. We've created ourselves a little formatter so that Darwin quotes are displayed up to 2 decimal places as they should be, as they are on the platform. And the axes are getting updated here repeatedly instead of new figures and axes being generated. The function in process stream passes the axis specific to the Darwin for which the data is being updated. And that axis is then accessed inside DWX graphic helpers, inside MPL plot axis, which goes ahead, formats the data as is required, constructs new minima and maxima for the Y limits, plots the latest n number of ticks, that n value specified by tailmax, an argument to MPL plot axis, and that's pretty much it. The tight layout is specified to keep things nice and concise, and we pause a little bit for about 0.01 seconds over here to allow the axes to catch up and to essentially not jitter on screen. That's your graphing functionality implemented there for you. Now, in terms of scaling this out to a terminal where you can scale to any number of Darwins, Matplotlib implementing this functionality is one option, but Plotly or Bokeh or using Plotly Dash is another option, probably the better option in terms of having a fluid interface to enable you to see things and have controls there to control the behavior of those things at the same time. So while Matplotlib in this case is particularly good for quickly creating a streaming example of Darwin data streamed into our Python application here, in future tutorials, we'll be employing Plotly Dash in particular to create this functionality so we can do something with it in real time too. For example, place an order, close an order, place conditional orders, and add indicators onto our charts with real-time data, specify levels for alerts, and things like that. Things from an algorithmic trader's perspective that are important for us to consider. So this functionality has been implemented for you in Darwinex Quotes API, a new class that sits inside the Quotes API folder that will be uploaded to GitHub after the publication of this video. To recap how the streaming is accomplished, we've modified the base class to construct a request object if stream is set to true, a new variable that we've added as an argument to the call API function. Once that request is returned to our application, it is subsequently prepared and sent off to the API via a session that is kept alive throughout the duration of our session. That then returns to us quote data in real time as and when the quote data is received, and that quote data is then passed on to our process stream function that performs two functions: stores the data in a data frame for us to be able to access later, and plots the data if we've specified plot to true. If plot is set to true, then the function MPL plot axis is invoked that requires an existing figure, a Matplotlib figure that is constructed here inside process stream prior to being sent off to the plotting function. The plotting function relies on the axis of the figure, the axes of the figure, in order to update the data in those axes and create a sort of real-time animation as opposed to using an actual animation function or component provided by Matplotlib. This implementation is absolutely fine for visualizing a number of Darwins that you'd like to see the behavior of, or if you'd like to visualize your portfolio with individual Darwins being displayed as singular charts, or if you'd like to visualize the total evolution of your portfolio quickly, then a terminal employing Matplotlib is useful. However, if you'd like to create something more detailed, as we will in future tutorials, like a Darwin trading terminal, or a Darwin trading visualization and backtesting terminal, all three things being part of our roadmap for future tutorials, then Matplotlib may pose some constraints that can be mitigated by using Plotly Dash. So hopefully you've enjoyed this tutorial series on implementing visualization and live streaming of Darwin quotes into your Python applications using the Darwin Quotes API. The Darwin Quotes API has one endpoint /quotes that requires you to submit product names as a list, and that is the only singular parameter that needs submission. As opposed to the Darwin Info API, where response objects are received by your functionality inside new classes. In this case, we are receiving an actual request object back that we are preparing and sending off via a session that is then kept alive, receiving quotes in real time as and when they come in for each of the Darwins that we've subscribed to, and the plotting logic as we discussed. As always, if you enjoyed this presentation, please do consider sharing it with your social networks, colleagues, co-workers, and friends. And do subscribe to the Darwinex YouTube channel so you remain up to date with all future videos that will be released in this series and other topics discussed on Darwinex. Thank you very much for your attention. See you next time.